When you think of the Arctic, you probably picture this vast, remote, frozen wilderness at the very top of our planet. And you're not wrong, but it's also something so much more important. It's a critical piece of our planet's operating system, a regulator for the global climate. And right now, that system is sending out a really clear, really urgent warning signal. So let's break down what that signal is actually telling us.
The first signal is just a single, stark number: 4. The Arctic is heating up 4 times faster than the rest of the globe. This isn't some subtle, gradual change we're talking about. It's a massive acceleration, and it's kicking off this whole cascade of consequences, kind of like pushing over the very first domino in a long, very complicated line. All that intense warming is basically giving the Arctic a fever. You can think of the polar regions as the planet's air conditioner. For thousands of years, all that bright white ice has reflected the sun's heat right back into space, which helped keep the Earth at a nice, stable temperature. But that air conditioner is starting to break down.
And look, this isn't just someone's opinion. This quote comes directly from the IPCC, the world's leading group of climate scientists. When a group that is this cautious and careful with their words uses a phrase like profoundly different, it's a huge red flag that a massive system-level change is already well underway.
So you might be asking, how can one place warm up 4 times faster than everywhere else? Well, it all comes down to a process called Arctic amplification. It's pretty straightforward, really. As the white, reflective sea ice melts away, it exposes the dark ocean water underneath. That dark water, instead of reflecting sunlight, absorbs it, soaking up heat. This warms the water, which then, you guessed it, melts even more ice. It's a powerful and frankly dangerous feedback loop that just keeps accelerating.
So, with all this amplified warming, where does all that heat go? It leads to what you could call the Great Thaw. And we are not talking about a little bit of melting around the edges here. We're talking about a fundamental change to the frozen parts of our planet.
And the scale of this is just staggering. This isn't a future prediction, this is real, measured data. It's showing us that the Greenland and Antarctic ice sheets have already lost trillions of tons of ice. But the most critical part of this graph is the curve itself. See how it gets so much steeper after the year 2000? That's the acceleration we were talking about. That's the feedback loop kicking into high gear. This great thaw is really happening on 3 main fronts. First, there's the sea ice, the frozen ocean itself, which is on a trajectory to completely disappear during Arctic summers. Second, you have the massive glaciers and ice sheets on land, like in Greenland, which are melting into the ocean. And third, there's the permafrost, the frozen soil that covers huge areas up north, which is starting to thaw. Each one of these is a massive problem on its own.
Let's just focus on permafrost for a second, because it is a terrifying wild card in all of this. This frozen ground isn't just rock and ice. It's packed with old organic stuff that holds an incredible amount of carbon, nearly double the amount that's in our entire atmosphere right now. As it thaws, microbes wake up and start releasing that carbon as CO2 and methane. There's a very good reason some scientists call it a ticking carbon bomb.
Okay, so why should any of this thawing at the top of the world matter to someone living thousands of miles away? Because the Arctic isn't some isolated place. It's connected to the rest of the planet through this massive engine of ocean currents that regulates climate everywhere. And right now, that engine is sputtering.
The main part of this engine is called the AOMOC. The easiest way to think of it is a global conveyor belt. It pulls warm tropical water northwards, where it releases heat in warm places like Western Europe. This process is absolutely fundamental to the stable climate we've known for basically all of human history. But the Great Thaw is throwing a giant wrench in the gears. Here's how it works. All that melting ice is dumping enormous amounts of cold, fresh water into the North Atlantic. This fresh water dilutes the ocean, making it less salty and therefore less dense. The whole AMOC engine is driven by cold, salty water sinking. But if the water isn't salty and dense enough to sink anymore, well, the whole conveyor belt slows down.
This quote really drives the point home, doesn't it? The changes that are happening in the Arctic don't stay in the Arctic. The stability of the poles is directly tied to the stability of the entire world's climate. It's a global engine, and when it starts to break down, we all feel the consequences.
Okay, so beyond these huge planetary systems, the thaw is having an immediate and honestly devastating impact on the life that has spent thousands of years adapting perfectly to this frozen world. For Arctic wildlife, this isn't some abstract threat in the future, it's a crisis that is happening right now.
This is a fascinating and really tragic story playing out in real time.
On one side, you have the Arctic fox, a total specialist, perfectly adapted with its white coat and other unique traits for the cold. But as the climate warms, its cousin from the south, the red fox, is pushing north. It's bigger, more of a generalist, and it's outcompeting the Arctic fox for food and territory. The specialist is losing out because its unique home is literally disappearing from under its paws.
And of course, we have to talk about the icon of the Arctic, the polar bear. For this animal, sea ice isn't just a platform to stand on. It's everything. It's their hunting ground for seals, it's their highway for travel, and it's their nursery for racing cubs. Without that ice, their entire way of life just collapses.
And this really gets to the heart of it. The impacts are felt most by the next generation. As the ice-free season gets longer and longer, mother polar bears have less time to hunt and build up the fat reserves they need to produce milk. And that means cubs are starving. The most vulnerable are the ones paying the highest price.
So let's bring all of this right back home. We've seen how the Arctic thaw rewires the planet's climate engine and devastates local ecosystems. Now let's look at how those ripples finally arrive right on our own doorstep.
Remember all that melting land ice from Greenland we talked about? Well, all that water has to go somewhere. This number here, 1.1 meters, represents the high-end projection for sea level rise by the end of this century. That's more than 3 feet. For hundreds of millions of people who live in coastal communities around the world, this isn't just a number, it's an existential threat. But the danger isn't just about the water slowly creeping up, it's about frequency. As this shows, rising seas lift the baseline level of the ocean. So a storm that used to cause a once-in-a-century flood could soon cause that same level of damage every single year. Think about that. It turns rare disasters into routine, predictable events.
And the impacts aren't just limited to the coasts. A warming Arctic can also disrupt huge atmospheric patterns like the jet stream. You know, that river of air high up in the atmosphere that influences weather for billions of us in the northern hemisphere. A wavier, slower jet stream can lead to more persistent and extreme weather. Things like long heat waves, droughts, and really severe storms.
Ultimately, the Arctic is acting as our planet's early warning system. It's the canary in the coal mine, telling us that something is deeply wrong. The profound changes we're seeing up there are really a preview of what's to come for the rest of the world if things don't change. The alarm bells are ringing, loud and clear from the very top of the world. The only question left is, are we going to listen?